You're welcome. Okay, 25 through 27 are systems. That's when we have two equations, and we have to find where they touch. So there were three methods to systems, to solving. You had substitution. Okay, you had big addition or elimination is what it's actually called. And then you had graphing. Well, none of these are set up for graphing. Graphing would be two y equals equations, type them in your calculator, see where they match. Okay, but this one is set up for substitution, and that's because one of them has a variable all by itself. So, I don't know if you remember, but we would set this up where this is our substitute, so that's going to go on the right. And this is what we're going to plug it into, so that's going to go on the left. So 6x minus 3y equals 5. And I know x equals negative 2y, so I can replace x with negative 2y and solve. So I get 6, and instead of x, I'm going to put negative 2y minus 3y equals 5. And I'm going to solve for y, and that's going to give me half of my solution, because remember, your solution is a point. It's a point where the two lines touch or intersect. It's where they're the same. And so I'm going to be able to fill in part of my point. So 6 times negative 2y is negative 12y. Bring down my minus 3y equals 5. Well, these are like terms. Negative 12 minus 3. If you struggle with negatives, please use your calculator. Negative 12 minus 3 is negative 15. So I get negative 15y equals 5. And now I have to divide. Well, I'm trying to get y by itself, so I'm dividing both sides by negative 15. I get y equals, well, my calculator's my BF during this stuff. And I'm going to type it in here so it'll simplify it for me. And I get negative 1/3, which you cannot write as a fraction. Do not tell me that's half my answer. That's my y, so negative 1/3 is my y. Do not tell me 0.33, because you can't plug that in and get the same answer. So now I know y equals negative 1/3, so I can replace y with negative 1/3. And I can solve. Well, again, calculator. So negative 2 times negative 1/3. And that gives me positive 2/3. So I know x equals positive 2/3. There is my answer. Now, you can type these in your calculator and solve. Well, I just typed this one, so I know that's right, because x is 2/3. I plugged in negative 1/3. That equaled 2/3. X is 2/3, so we're good. But I can plug it into the first equation, 6, and instead of x, I'm going to type alpha y equals enter 2/3, because that was my x, minus 3 times alpha y equals enter negative 1/3. And when I press enter, it should equal 5, and it did, so there's my answer. I'm done. I did it correctly. Now, number 26, I would solve with big addition because they're both in standard form. Now, I noticed that right away my y's, they're smaller numbers, and one's already negative, one's already positive, because remember, you have to create a zero pair, and I know 3 times 5 is 15, so they could both turn into a 15. How do I turn a negative 3 into a negative 15? I'm going to multiply by 5, and if I'm turning that into a negative 15, I need this to be a positive 15, so let's multiply that first. 5 times 4x is 20x. 5 times negative 3y is negative 15y. And then 5 times 7 is 35, I believe. Why am I second guessing myself? 5 times 7. Yes, I was right. Okay, so there's my first equation. I'm trying to cancel my y's. So I need this equation to have a positive 15y to cancel. So how would I turn 5y into a positive 15y? I would multiply by 3. Well, 3 times 7x is 21x. 3 times positive 5y is positive 15y. And 3 times 2 is equals 6. So now I can do my big addition. This zeroes out. If I don't have a zero pair, this isn't going to work. 35 plus 6 is 41. 20x plus 21x is 41x. If I divide both sides by 41, I get x equals 1. So there's half my answer. X comma y, x is 1. Now it doesn't matter which equation. Pick either one. I'm going to pick the bottom one because it has all positives. And now it's like substitution. I need to plug in my x is 1. So I have 7 times 1 plus 5y equals 2. Well, 7 times 1 is 7. I'll do minus 7 because I need to get y by itself. I get 5y equals negative 5. Divide by 5, divide by 5. I get y equals negative 1. There is my answer. And again, I can check my work. So 4 times 1 minus 3. I think standard form is easier to check your work because whatever it equals is right there. Equals 7. That worked. 7 times 1 plus 5 times negative 1 equals 2. There you go, it worked. That is my solution. Okay, last one, I would say this is set up for substitution because I have y by itself. So now I know that that's my substitute. And then I'm going to bring my right side, 3x minus 6 equals y plus 4. Well, I know y equals this, so I'm going to rewrite it 3x minus 6 equals, and instead of y, I'm writing 3x minus 10 plus 4. Well, I don't need that parentheses because there's nothing in front. There's an equal sign in front, can't distribute an equal sign, and there's no exponent or nothing, so I can ignore it. So I have 3x minus 6 equals, well, negative 10 plus 4 minus 6. So I'm going to get my x's, both my x's are the same, so it doesn't matter which one I move, minus 3x, but they both zero out. Does negative 6 equal negative 6? Well, yeah, that's true, so this is infinitely many solutions, IMS. Now, if it was false, what if I had like negative 6 equals 0, or negative 6 equals 10, or anything that's false, my answer would have been no solution. But because it was true, it's IMS.